In this, now I am going to evaluate integrals of these three forms. Observe these three forms. In the first one, in the numerator place, there is x square plus or minus 1. In the denominator, x to the power of 4 plus lambda x square plus 1. And come to the second one. So in the numerator part, only x square is there. In the denominator part, same like previous one. And come to the third one. In the numerator plus 1 is there. So in the denominator part, as above. So in these three types of models, so the substitution is either x plus 1 by x equal to t you have to take, or x minus 1 by x equal to t. I explain you along with some examples. Now let me explain you those examples. Observe the three integrals where lambda is a parameter. What is lambda here? It is a one constant which belongs to a real number. Now let us see few examples based on these models. See the first one, x square plus 1 by x to the power of 4 plus 1 dx. So in this, to evaluate this function integral, you would have to take x square common from numerator as well as denominator. If I take x square common from the numerator, so here what do you get? 1 plus 1 by x square. In the denominator also, so here x square plus 1 by x square dx. Now after this, let us take x minus 1 by x equal to 2 is the substitution. As I said to you, in all these models, you would have to take either x plus 1 by x equal to t or x minus 1 by x equal to t. Here why I am taking x minus 1 by x equal to t? Because in the next step, we are going to do differentiate on both sides with respect to x. So here if I take a differentiation on both sides with respect to x, it is going to be 1. So here minus 1 by x differentiation is plus 1 by x square, which is equal to dt by dx. You know this. So here you got the numerator. So here plus is given means you have to take minus as substitution. Here sometimes in some applications they will give you here minus. In such case you have to take here x plus 1 by x. Because if you take here plus 1 by x, after the differentiation, here you get minus sign. Okay, observe this. Here if plus is given, you have to take minus. Here minus is given, here you have to take plus. So in the next step, take this dx to the left side. So that what do you get? 1 plus 1 by x square dx, which is equal to dt. Now go to the numerator part. In the numerator part, what you have to write? dt in the next step. But in the denominator, what is there? X square plus 1 by x square is there. So here we have assumed this as t na. Take the square on both sides, so that you will get x square plus 1 by x square minus 2, which is equal to t square you will get. Now x square plus 1 by x square, which is equal to t square plus 2. Okay students. Now in the numerator part, what you have to write? dt. Come to the denominator part, in which what you have to write? T square plus 2. So this 2 you can write as t square plus root 2 whole square. In the next step, what should I write? It is looking like this integral, standard integral 1 by x square plus a square dx. As we studied, whose integral value is 1 by a tan inverse of x by a plus c. Now apply this formula for this so that you get 1 by a. In the place of a, what is there? Root 2. 1 by root 2 tan inverse of your x value t by a value root 2 plus c. Now what is t here? X minus 1 by x. So replace this t by this so that you get 1 by root 2 tan inverse of x minus 1 by x by root 2 plus c. Still if you simplify, 1 by root 2 tan inverse of x square minus 1 by root 2x plus c. So this is your required integral for the given function. I hope you have understood this. Now let us go to one more application based on this concept. See this. Integral of x square plus 1 by x square plus x plus 1 dx. Now in this, see here it should be x to the power of 4, here it should be x square. Now evaluate whose integral. So in this one also you would have to take x square common from the numerator as well as denominator, because it is looking like our standard form. As I said to you, in this class we are going to evaluate integrals of this kind of forms. In the beginning itself I said to you, so this is one of the form of the three given integrals. So in this type, what you people have to do? So you have to take the substitution as x plus 1 by x or x minus 1 by x. When you have to take that substitution, after taking x square common from the numerator as well as denominator. Now take that x square common from the numerator as well as denominator. Here what do you get? 1 plus 1 by x square by x square plus 1 plus 1 by x square dx. So these two get cancelled. Now here plus is there. So as you know, if plus is there, what you have to take? X minus 1 by x equal to t common. Same like previous one. So go for the derivative on both sides with respect to x. Which is dx, which is equal to dt you will get. So now take the square on both sides. What do you get? X square plus 1 by x square, which is equal to t square plus 2 you will get. Same like previous one. Now this can be written as integral of, see in the numerator part, you have to write this dt by, here x square plus 1 by x square value is t square plus 2. So here plus 1 is there. So finally this can be written t square plus 2 plus 1, 3. 3 can be written root 3 whole square. Now apply the previous formula, 1 by a tan inverse of x by a, so that you will get 1 by root 3 tan inverse of t by root 3. T means what? X minus 1 by x. So after simplifying, x square minus 1 by root 3x you will get plus c. So this is your required result for the integral of this function. This is one of the rational polynomial function, or you can say it as a rational fraction or simply rational function. The integral of this rational function is 1 by root 3 tan inverse of x square minus 1 by root 3x plus c. Okay students? So sometimes, see, here they may give you minus. They may give you minus. So in such case, same procedure. Take x square common from the numerator. From the denominator also x square common. So here 1 minus 1 by x square by x square plus 1 plus 1 by x square dx. Cancel. Here what is the substitution? X plus 1 by x. Because here minus is given. So that you would have to take x plus 1 by x is the substitution. Now do the derivative on both sides with respect to x. 1 minus 1 by x square, which is equal to dt by dx. So in the next step, what do you do? So in the numerator part, you have to write dt. Okay? And come to the denominator, take the square on both sides, so that you will get x square plus 1 by x square, which is equal to t square minus 2 you will get. The previous one you got there plus, because here we took minus. If you take square on both sides for this, you will get x square plus 1 by x square equal to t square minus 2. So you write, in place of x square plus 1 by x square, I am writing this x square minus 2. So here plus 1 is there. So finally it becomes dt by t square plus 1, which is nothing but tan inverse of t. So here what is t? X plus 1 by x plus c. So tan inverse of, so take cross multiplication. So you get x square plus 1 by x plus c. So this is your required integral value of this function. Okay students. So sometimes they may write here minus sign. Okay. So they may write here minus. Okay students. Sometimes they will write here plus and here minus. So in all these cases, same procedure. Here if minus is given, what is the substitution? X plus 1 by x is equal to t. Here suppose plus is given, x minus 1 by x equal to t is the substitution. Okay students. See, in the current one, here I gave you minus, here plus. You do, here take plus, here minus. Here minus, here minus. You try it. Okay students. Right. Now let us go to one more model based on this. See, integral of x square by x to the power of 4 plus 1. In this case, how do you evaluate it? How do you evaluate integral of this? Observe the previous one and this one. In the previous examples, I took there like plus or minus 1. But here only I kept x square, in the denominator x power 4 plus 1. Now how do you evaluate whose integral? See, in this I would like to write 1 by 2 2x square x to the power of 4 plus 1 dx. What did I write? I multiplied numerator and denominator with 2. In the next step, I am going to write this one as x square plus 1 and x square minus 1. Can I write? See, observe this. Just wantedly I wrote a plus 1 and minus 1 over here. In the next step, you can write this one as 1 by 2 integral of x square plus 1 by x to the power of 4 plus 1 dx, and this one 1 by 2 integral of x square minus 1 by x to the power of 4 plus 1 dx. Okay students. and you know how to evaluate whose integral and how to evaluate whose integral. Okay, in the first application of this class, I taught to you how to evaluate it, and this one also you know how to evaluate. If you want, again I can do. See, in this one what you have to take common? X square common, here x square common. There also take x square common from numerator and denominator and cancel. So finally what do you get? 1 by 2 integral of 1 plus 1 by x square by x square plus 1 by x square dx plus there also 1 by 2 integral of 1 minus 1 by x square by x square plus 1 by x square dx. Okay students, now evaluate it. So what you have to take here? What is the substitution for this? X minus 1 by x equal to t. For this, x plus 1 by x equal to t. Yes, go for the derivative on both sides. So that what do you get in the numerator? 1 by 2. So here, dt you will get. What about this x square plus 1 by x square? Take the square on both sides. You will get t square plus 2. And there also, in the numerator portion, so dt come to the denominator. So you get here t square minus 2 you will get. So if you integrate it, you get tan inverse of here x by a, 1 by a. So here 1 by a becomes root 2 whole square. How you have to write this? Root 2 whole square. So 1 by a value root 2, tan inverse of x by a, t by a. What is t here? X minus 1 by x by root 2. And what about this? 1 by 2 into 1 by root 2, tan inverse of, here what is the substitution? X plus 1 by x by root 2 plus c. This is your required result for the integral of given function. What is the given function? Integral of x square by x to the power of 4 plus 1 dx. Okay students, I hope you have understood this. See, sometimes, see, given integrals will be like this. X square by x to the power of 4 plus x square plus 1. Observe the previous one and this one. In the previous one, in the denominator plus, only x power 4 plus 1 was given. But here, x power 4 plus x square plus 1. Sometimes they may write here minus also. But procedure is same. Here I took in the place of lambda as plus 1. Sometimes they will write here minus 1 also. Okay students. So in such cases, same like previous one. Numerator and denominator you would have to multiply with 2. X to the power of 4 plus x square plus 1 dx. Then how you have to split the numerator? X square plus 1 by x to the power of 4 plus x plus 1 dx. And here 1 by 2 integral of x square minus 1 by x to the power of 4 plus x square plus 1 dx. So hereafter, so you have to take x square common from the numerator and denominator. Later on you have to take x plus x minus 1 by x equal to t. There also x minus 1 by x equal to t. If you do like that, what do you get in the numerator plus? Here for this, what is the substitution? So take x square common from the numerator and denominator. So you get, take common and cancel. What will be left in the numerator plus? 1 plus 1 by x square by x square plus, sorry here, x square should be given. So x square plus 1 plus 1 by x square. Here 1 by 2 integral of 1 minus 1 by x square by x square plus 1 plus 1 by x square dx. Now what do you do, students, thereafter? So it must be taken as 1 by x equal to t. And what about this? For this, what is the substitution? X plus 1 by x equal to t. Now do the derivative on both sides with respect to x, and so that in the numerator will become dt by in the denominator portion. So in the place of x square plus 1 by x square, what do you write? T square plus 2. T square plus 2, here already 1 is there. 2 plus 1, which becomes 3. So here this one also 1 by 2. So numerator part will become dt. And what about denominator? T square minus 2 plus 1. So t square minus 1 you will get. Am I right, students? So take the square on both sides. So what do you get? T square minus 2. So in place of this, t square minus 2 and minus 1. You know how to integrate this. 1 by 2. So here 1 by a, tan inverse of x by a. So t by root 3. T means in the place of t write x minus 1 by x. But what about this? How does it look like? So if you take square on both sides, x square plus 1 by x square plus 2, which is equal to t square you will get. When you transfer 2 to the right side, t square minus 2. T square minus 2. But what is there? Plus 1 is there. If you add plus 1, which becomes t square minus 1. So, you know, okay, what is the integral of this function? It is looking like this formula. 1 by x square minus a square dx, whose integral value will be 1 by 2a log mod x minus a by x plus a plus c. Apply that formula so that you will get 1 by 2 into here 1 by 2a, a value 1. 1 by 2 log mod x minus a, t minus 1 by t plus 1 plus c. In the place of t, write this x plus 1 by x minus 1 by x plus 1 by x plus 1. So this will be your required integral value of the given function. Understood, students? Now let us go to one more model based on this concept. See that 1 by x to the power of 4 plus 1 dx. Are you observing? In the first one, in the numerator place, I took x square plus or minus 1. And next, x square we took in some problems. Next, what is getting in the numerator? 1. In this case, directly we took x square common and we did the solution. And in this type of models, we multiplied numerator and denominator with 2. And this numerator part 2x square we split as x square plus 1 and x square minus 1. And we did the solution now. Now, what is given in the numerator? 1 is given. In all these applications, in the denominator portion, either x power 4 plus 1 or x power 4 minus 1 or x power 4 plus x square plus 1 or x power 4 minus x square plus 1 are getting. In all these applications, like in the beginning itself, I said to you, in this class what you people are doing, we are evaluating integrals of three forms. In the beginning, I mentioned those three forms. Okay? So, in all this, in the denominator places, either this or plus or this or here minus. So, just here I kept lambda. As I said to you, lambda is a real number. Mostly, you will get either plus 1 or minus 1. If other than plus 1 or minus 1 is given, even though you can do same procedure. Okay, students? Right. Now, how do you evaluate it? Tell me. So, in this, see, observe me how I am going to do. So, numerator plus, see, 1 by x to the power of 4 plus 1 is given, na? Right. See, I would like to write 1 by 2 into 2. This is the first step which we have to write. Numerator and denominator I multiplied with 2. In the next step, in the numerator portion, I would like to write x square plus 1 minus x square minus 1. In the denominator, x to the power of 4 plus 1 dx. So if you simplify this again, you will get 2 na. So this 2, just I wrote like this. You can. In the next step, what do? We divide this by this and this by this. So that you will get two integrals. So 1 by 2 integral of x square plus 1 by x to the power of 4 plus 1 dx. And what about this? Minus 1 by 2 integral of x square minus 1 by x to the power of 4 plus 1 dx. You know how to evaluate these two integrals. We come across these two now in this class. So, follow that method. Take x square common from the numerator and denominator there also. If you want, I can do it. So, here what do you get? 1 plus 1 by x square by here x square plus 1 by x square dx. Here also 1 minus 1 by x square by x square plus 1 by x square dx. So here, what is the substitution for this? X minus 1 by x equal to t. For this, x plus 1 by x equal to t. So in the numerator, what do you get? dt by in the denominator portion, t square plus 2. 2 can be written root 2 whole square. So this one also minus 1 by 2 integral of dt by in the denominator square on both sides. So you will get t square minus 2. Minus 2 you can write as root 2 whole square. Okay students. So which looks like x square minus a square. So what is the integral formula for this? 1 by 2a log mod x minus a by x plus a. For this 1 by a tan inverse of x by. Apply those two formulas so that you will get whose integrals. Like this you people have to do this kind of model. Yes? Right. Next. Sometimes, so they may give you like this. Integral of 1 by, so x to the power of 4 plus x square plus 1 dx. Now what do? Same like previous one. So you would have to multiply numerator and denominator with 2. In the numerator place, in the next step, what you have to do? Tell me students. X square plus 1 minus x square minus 1 by in the denominator x to the power of 4 plus x square plus 1 dx. Here they may give you plus or minus. So in the next step what you have to do? You have to separate this by this. And this one also. X square minus 1 by x to the power of 4 plus x square plus 1 dx. So already you have learned how to integrate these functions in this class. So follow that methods and obtain whose integral results and come back and substitute over here so that you will get your required result. Okay students, I hope you have understood this class. Thank you.